Today let us discuss angle sum property. Okay, what is this angle sum property? Okay, first, if the sum of the angles in a triangle is 180, if the sum of the angles in a triangle is 180 degrees, it is called as angle sum property. Okay, now let us see the proof of this. Okay, for that let us consider a triangle. Okay, let us consider the triangle PQR. Okay, let us consider triangle PQR and let us name these angles as angle 1, angle 2 and angle 3. Okay, so in order to prove this, sum of the angles in a triangle is 180. What we are considering is, we are considering a parallel line to this QR. Okay, and which is passing through the point P. And this parallel line is making angles as 4 and 5. Okay, it is making two angles, that is 4 and 5. So let us start the proof. First what we will write is, given, that is triangle PQR we have. Okay, what we have done, we are drawing a parallel line passing through P. Okay, so now it is making two angles there. Those are angle 4 and angle 5. So let us name this parallel line as AB. Okay, now what you have, AB is parallel to QR. Okay, now here if these two are parallel lines, then this PR will become the transversal. Okay, then we are having two angles, that is 5 and 3. Those will be same, that is angle 3 is equals to angle 5 because they are alternate interior angles. Okay, let us name this as first equation. Now this side if you see, again this PQ is a transversal. Okay, PQ is a transversal. Again here also we are having angle 2 is equals to angle 4 because this is the reason, again alternate interior angles. Okay, here what was the transversal? PR was the transversal. Okay, and here PQ is transversal. Okay, now this naming it as 1 and 2. Now if you see here, this AB is a line, right, and it is forming a linear pair here. Okay, so AB is a straight line, it is forming a linear pair, that is angle 4 plus angle 1 plus angle 5 is equals to 180 degrees. What is the reason here? Linear pair. Okay, these three angles are forming a linear pair here. But from the equation 1 and 2, what do I have angle 3 as? Angle 5 as I have angle 3, angle 4 I have as angle 2. So I am replacing those values again. So 4 is being replaced by 2 plus 1 plus 3 is equals to 180. By arranging I will get angle 1 plus angle 2 plus angle 3 is equals to 180. Therefore it is proved that the sum of the angles in a triangle is 180 degrees, and this is called as angle sum property. It is called as angle sum property. Now let us see one more theorem, that is, if a side of a triangle is produced, then the exterior angle so formed is equal to the sum of two interior opposite angles. So let us draw a figure for this first. Let us consider a PQR triangle. Okay, and what is given? If a side of a triangle is produced, so it is being produced to a point S. Okay, then the exterior angle, so let us consider this is an exterior angle because it is outside the triangle. Let us consider this as 4. This exterior angle, let us name this as angle 1, angle 2 and angle 3. So this exterior angle so formed is equal to the sum of two interior opposite angles. So for this 4, these two are opposite interior angles. So what we have to prove? We have to prove that is exterior angle is 4 is equals to angle 1 plus angle 2. This we need to prove. Okay, so for this what we will do is, first let us consider that triangle PQR. Okay, in that angle 1 plus angle 2 plus angle 3 is equals to 180 degrees. Why? Because of what reason? Angle sum property, because sum of the angles in a triangle is 180. You know, just now we proved it, right? That is the first case. Second case is, if you see here, this is a straight line and this straight line is forming a linear pair here. That is angle 3 plus angle 4 is equals to 180 degrees. What is the reason here? Linear pair. Okay, and name it as equation number 2. Now if you see this both equation 1 and 2, I am having this 180, 180. So I will equate these two parts. That is 1 and 2. If I am equating, I will be getting it as angle 1 plus angle 2 plus angle 3 is equals to angle 3 plus angle 4. You know, if I shift this angle 3 that side, it will become angle 1 plus angle 2 is equals to angle 3 plus angle 4. As this is plus 3, it will become minus of angle 3. So plus and minus gets cancelled. We are having angle 1 plus angle 2 is equals to angle 4. So therefore, if I arrange it properly, the exterior angle is angle 4 is equals to the sum of opposite interior angles. Hence proved. Now let us solve problems of exercise 6.3. Okay, the first problem is, in the figure, sides QP and RQ, that is QP and RQ of a triangle PQR are produced to the points S and T. So this QP is produced to the point S and QR is produced to the point T, and also the angle, that is SPR angle, is 135 degrees and PQT angle is 110 degrees. Okay, then we have to find out PRQ. We have to find out this angle is equals to how much. Okay, for that, see here, this SQ is a straight line, right? It is forming a linear pair here, right? So what we can write there, if I consider this as angle, first the solution what we will write is triangle PQR. We have in that what are given to us, SPR is equals to 135 degrees and PQT is equals to 110 degrees. Okay, so let us take this first linear pair, that is SPR plus RPQ is equals to 180 degrees because they are forming linear pair. Okay, so SPR we have as 135 degrees. So 135 plus RPQ is equals to 180 degrees. From that, RPQ will be equals to 180 minus 135 degrees, which will be equals to how much? 180 minus 135 will give you 45 degrees. So therefore we got angle RPQ as 45 degrees. Okay. Next, now let us find out this angle. Okay, again here if you see, it is also forming a linear pair here, right? TR is a straight line and the angle is being formed here, that is linear pair. So let us take that pair now, that is by TQS plus PQT, that is nothing but 110. Okay, let us write the same thing here, that is PQT, because we have that PQT plus PQR. PQR is equals to 180 degrees because they are forming what? Linear pair here. Okay, but PQT is given as 110, so 110 plus PQR is equals to 180 degrees. From that, PQR is equals to 180 minus 110, which is equals to 70 degrees. So we got PQR as 70 degrees. So now this we got as 70 degrees. The previous one we got as 45 degrees. Now we can easily find out this by using angle sum property, right? By angle sum property. What we can write? QPR plus PRQ plus RQP is equals to 180 degrees. Okay, so in this QPR is nothing but P angle, which is 45 degrees, plus we have to find out this PRQ plus 70 degrees is equals to 180 degrees. So from this, 70 plus 45 will become what? 115. 70, 100, 115 degrees plus PRQ is equals to 180. From that, PRQ is equals to 180 degrees minus 115 degrees, which will give you 65 degrees. Okay, therefore the required angle, that is PRQ, is equals to 65 degrees. Now let us start second problem, that is in figure angle X is equals to 62 degrees and angle XYZ is 54 degrees, and if YO and ZO are the bisectors of angle XYZ and XZY respectively of a triangle XYZ, find OZY and YOZ. So we have a triangle XYZ, right, and we are having a YO which is bisecting the angle Y, and we are having ZO which is bisecting the angle Z. Okay, so we have to find out OZY, that is OZY, this angle we have to find out, and YOZ, this angle also we have to find out. Okay, for that, first what we will do is, by using angle sum property, let us find out Z angle first, because I have this X as 62 degrees, Y as 54 degrees, and we can find out Z angle by using angle sum property. Okay, so now what we will do is, let us put the heading as solution. In triangle XYZ, okay, in triangle XYZ, what we will write is angle X plus angle Y plus angle Z is equals to 180 degrees because of the reason angle sum property. Okay, so but angle 2 is, X is given as 62 degrees, angle Y is given as 54 degrees plus angle Z is equals to 180 degrees. 62 plus this will become how much? 116 degrees plus angle Z is equals to 180 degrees. Okay, from that angle Z is equals to Angle Z is equals to 180 minus 116. So from that, angle Z will be equals to 64 degrees. Okay, angle Z is equals to how much? 64 degrees. So we got angle Z now. Now let us see, OY is the bisector of this angle. Okay, OY is the bisector of Y. OY is the bisector of angle Y. That means OY will be equals to what? 54 divided by 2, which is equals to 2 ones, 2 twos, 2 sevens. So 27 degrees. So therefore, angle at the point Y will be what now? OYZ. That is, OYZ will be equals to 27 degrees. Okay. Now similarly here, okay, similarly here OZY, angle OZY is the bisector. OZY is the bisector of angle Z. Okay, here also let us take it as Z, angle OYZ, so it will become very easy. So OZY is the bisector of angle Z. Okay, but we have angle Z as what? 64. So therefore, angle OZY will be equals to 64 by 2, which is equals to 32 degrees. Okay, so therefore OZY is equals to 32 degrees. Next, we got this Z now, right? We got this OZY. This is over. Now we have to find out YOZ. For that, if you take this small triangle, I have this OYZ as 27 degrees and this OZY as 32 degrees. Can we find out this O? Yes, by taking what? Angle sum property. That is, by using angle sum property again, angle YOZ plus OYZ plus OZY is equals to 180 degrees. In that, YOZ we don't have, which we have to find out, plus ZY is nothing but, YZ is nothing but 27 degrees plus 32 degrees is equals to 180 degrees. From that, angle YOZ is equals to 180 minus, this will become how much? 59 degrees. Okay, so therefore angle at YOZ will become 121 degrees. Okay, 121 plus 19 will give you 180. So therefore angle YOZ is equals to 121 degrees and OZY is equals to 32 degrees. Now let us solve third problem of this exercise 6.3. That is, in the figure, if AB is parallel to DE, this AB line is parallel to DE and BAC is 35 degrees, BAC, that is BAC is 35 degrees and CDE is 53 degrees, CDE is 53 degrees, then we have to find the angle DCE is equals to how much? Okay, so let us write the solution. That is, given that AB is parallel to DE. If AB is parallel to DE, AE will be the transversal. AE is the transversal. If AE is the transversal, then BAE, angle BAE will be equals to CED. Will be equals to same. Why? Because what is the reason? Alternate interior angles. Okay, so BAE is 35 degrees. BAE is 35 degrees. So this also will become 35 degrees. That is CED also 35 degrees. Okay, so we got this CED. Now we have to find out DCE. Now this is a triangle. CDE is a triangle. So by angle sum property, by angle sum property, we can write what we can write, DCE plus CED plus EDC is equals to 180 degrees. So from that, DCE is equals to will be 35 plus 53 is equals to 180 degrees. So DCE plus these two, if you add, it will become 88 degrees is equals to 180 degrees. So from that, DCE will be 180 degrees minus 88 degrees. So it will give you DCE is equals to 180 minus 88 will become what? 217 minus 92 degrees. Okay, 92 degrees. So therefore DCE angle is 92 degrees. Now let us discuss the fourth problem of this exercise, that is, in the figure, if line PQ and RS intersect at the point T. So PQ and RS both are intersecting at the point T, okay, such that PRT is 40 degrees, PRT is 40 degrees and RPT is 95 degrees, RPT is 95 degrees and TSQ is 75 degrees. We have to find out SQT, this we have to find out. Okay, so in order to find this, let us consider this into two triangle. This is one triangle, this is another triangle. So as I don't know this angle, I am taking it as X. Okay, so what I'll write is, consider, let me write that in triangle PRT, okay, angle P plus angle T plus angle R is equals to 180 degrees. What is the reason here? Angle sum property. Okay, so angle P is 95 degrees plus T I am taking it as X, R is 40 degrees, which is equals to 180 degrees. From that, 90 plus 40 will become 135 plus X is equals to 180 degrees. From that, I will be getting X as 180 minus 135 degrees, which will give me X as 45 degrees. So therefore, I found the value of X as 45 degrees. Okay, so now what is given in the question? We have PQ and RS are intersecting. Okay, as they are intersecting, we will form, these two lines will form vertically opposite angles. So that is PTR is equals to STQ is equals to 45 degrees. Why? Because they are vertically opposite angles. Why? Because they are vertically opposite angles. So now this became 45 degrees. Now again, here I can apply angle sum property by angle sum property in triangle SQT. Okay, that is angle S plus angle Q plus angle T is equals to 180 degrees. So this will become angle S is 75 plus angle Q I don't have, so let it be angle Q plus angle T is 45 degrees, which is equals to 180 degrees. 75 plus 45 will become what? 120 degrees plus angle Q is equals to 180 degrees. From that, angle Q is equals to 180 minus 120. So therefore, angle Q is equals to 60 degrees. Angle Q is nothing but what? SQT. So therefore, angle SQT is equals to 60 degrees. Now let us discuss the fifth problem of this exercise. That is, in the figure, if PQ is perpendicular to PS, PQ is perpendicular to PS, and this PQ is parallel to SR, as well as SQR is 28 degrees, SQR is 28 degrees, and QRT is 65 degrees, then we have to find out the values of X and Y. So what is given to us is given PQ is parallel to SR. If this is parallel to this one, then what will get? PQR is equals to QRT is equals to 65 degrees. Why? Because alternate interior angles. Okay, but this angle PQR is a combination of X plus 28 degrees is equals to 65 degrees. Why? Because angle PQR is equals to X plus 28 degrees. Okay, so from this X will be what? 65 degrees minus 28 degrees. From that X will become 37 degrees. So we found the value of X as 37 degrees. So this X value become 37 degrees. Okay, now we have to find the value of Y. So in this we can consider the triangle PQS. Okay, here by angle sum property, what we can write? Angle P plus angle Q, that is angle X, let us write angle Q plus angle S is equals to 180 degrees. Okay, so this is nothing but our Y. Okay, so P is 90 degrees plus Q we got it as 37 degrees plus angle S is equals to 180 degrees. So 90 plus 37 will become 127 plus S is nothing but Y is equals to 180 degrees. From that Y will be equals to 180 minus 127 degrees. So from that Y is 53 degrees. Okay, so therefore the value of Y is 53 degrees and the value of X is 37 degrees. Sixth problem of this exercise, that is, in the figure, the side QR of a triangle PQR. So this is the triangle PQR. So QR of a side of a PQR is produced to the point S. Okay, if the bisectors of PQR, that is angle P bisector, and PRS meet at the point T, these two are the bisectors, they are meeting at the point T, we have to prove that QTR is equals to half of QPR. Okay, so let us take this as B, this as B, this as A, this as A, and this complete will become 2A, this complete will become 2B. Why I am taking it as B and B? Because it is an angle bisector, the angle will divide into two halves there. Okay, so now let us consider triangle QTR. Here, by using the exterior angle property, that is, the angle which is out of the exterior angle is equals to sum of the interior opposite angles, right? By using that property, exterior angle property, I can write it as angle B is equals to angle A plus, here I don't have any angle, so I am writing it as QTR. Okay, what is the reason? Exterior angle property, exterior angle property. Okay, from this QTR can be written as what? QTR can be written as angle B minus angle A, and name it as equation number 1. Okay, now let us consider triangle PQR. Okay, in that, what is the exterior angle here? 2b is the exterior angle. So this 2b is equals to opposite, interior opposite angles. That is 2b is equals to 2a plus angle QPR. What is the reason here? Exterior angle property. Okay, so from that 2b minus 2a is equals to QPR. If I take 2 common, I will be having b minus a is equals to QPR. Okay, so now from this, if I shift this to that side, it will become what? B minus a is equals to 1 by 2 times of QPR. Right? Let us be equation number 2. If I see this 1 and 2, I have b minus a, that is b is nothing but angle. Okay, I have angle b minus angle a as QTR. Okay, from 1, what I can write? QTR is equals to half of QPR. Therefore, hence proved.